So let's now write the method to actually reduce the fraction. So in addition to knowing if a fraction is reduced, you might want to modify a fraction to reduce it, right? So we now want to have a public facing method. And I'm going to call it reduce. And of course, I don't need to take in any parameters. Now you might want to think about what this return type should be. I think it could make sense for it to be void because this method is going to accomplish a task. It's going to reduce the fraction and then be done. You could also potentially think about creating it as a Boolean because perhaps the fraction is already reduced. And so if it's already reduced, maybe you return a false to say, nothing was changed. And if you change it, maybe you return a true. So both of those could be valid, valid approaches and valid return types. So you just have to kind of think about, what do I want this method to do? Do I want it to give me some sort of flag afterwards telling me whether it reduced the fraction or not? So I'm going to leave it as a void method, but it would be valid to have it as a Boolean as well. So what I want to do here is I want to say, well, if my fraction can be reduced, I can again take that greatest common factor and I can just divide the numerator and the denominator by that factor, and that will reduce my fraction. But I only need to do that if it's not already reduced. So I'm going to put all this code inside a conditional that says, well, let me invoke is reduced, and if the fraction isn't reduced, then I'll go ahead and reduce it. If it already is, I don't have to do anything. So note here again, as we did in the previous methods, you can invoke a method from within the class directly. You don't need an invoking object. You do have the option of using this as your invoking object, but it's not required because we're in the same class where that method exists. So what I want to now do is, well, if it's not reduced, I want to find out what that greatest common factor is. And I can do that just by invoking my method with the numerator and the denominator. And then I can just update my instance data variables. So I can say the numerator gets a numerator divided by that factor, and the denominator gets the denominator divided by that factor. Now, do I need to worry about integer division here? I don't. And why is that? Well, I know that this number is evenly divided by this number because this number is a factor. So I don't have to worry about there being any decimal portion. So in this case, I don't need to worry about integer division, but it is always good to stop and check yourself to make sure, do I need to worry about this or not? So let's check out that reduce. So let's see. So let's invoke reduce on fraction 7, and then we'll print it out. Print it out before and after. So fraction 7 was 2/8. It gets reduced to 1/4. If we were to use what's one of those, fraction 6, which is a half, it would just be a half and then a half. It wouldn't change. Okay, so again, we'd want to run more test cases than just that to convince ourselves our method was working, but that just gives you a little demonstration of the method. One other thing I want to note about these things, like the greatest common factor and even the value, is that a common mistake I see is having things like that stored as instance data variable. So perhaps something like private int greatest common factor. You might think, well, I'm calculating this thing a bunch of times. Why don't I just store it as an instance data variable? And then it's always there when I need it. And as a general rule of thumb, you want to avoid storing data that's kind of the combination or summary or result of combining other pieces of data. In a way, you're duplicating it, right? I always can find the greatest common factor from the numerator and the denominator, so storing it is kind of a duplication. And that's one way to think about it. But the other way to think about it is just that this is very difficult to manage and make sure you keep in sync, right? Because anytime the numerator or the denominator changes, you have to also make sure to update that greatest common factor. And it's easy to forget to do that. So it could be possible that you'd introduce a bug where the numerators change, but you didn't update the greatest common factor. So anytime you have kind of a summary piece of information, in this case it's greatest common factor, it's not much of a summary, it's more a combination of the two instance data variables. But anytime you have summaries like totals or averages or things like that, it's best to not store them as an instance data variable and just calculate them as needed. Okay. Now, again, that's not a hard and fast rule, particularly if the calculation to figure out that piece of information is incredibly complex and time consuming, maybe you'd make a different choice. But for sort of simple summaries or simple pieces of data like this, it's best to calculate it when you need it rather than store it, to make sure that your code is more, it's not brittle, right? It's more flexible. It's easier to maintain and keep accurate. You always want to write code with an eye for making it easy to maintain correctly. All right, so that's our reduce. Now we want to find the lowest common denominator with some other fraction that's passed in as a parameter. So again, if you don't remember about lowest common denominator, go ahead and take a look at this page that I've linked to from the PDF and give yourself a little refresher. Essentially, the denominator, if you have two fractions that you want to add together, you need to find a common denominator. So if you want to add a third and a sixth, in order to do that, you need to make sure they have the same denominator. So you want to find the lowest possible common denominator. In this case, it would be 18. And then you want to, modify those fractions to have that denominator. And then you can do things like add them together. Okay. You want to always we often use the least common denominator because you want to kind of have the smallest number possible on the bottom. So instead of having 18 as your denominator for 1/3 and 1/6, we could just use 6. Okay. Because that allows us to just modify this fraction to be 2/6 rather than this one, and rather than modify them both to be able to add. So again, take a look at this least common denominator if you need a little refresher on that. But what we're going to do is we're going to say, well, okay, perhaps I want to be able to add two fractions in together. So I'm going to give you a fraction and you're going to tell me what the least common denominator is. All right. Now this potentially could be a private method. If we were writing a method to actually add two fractions together, maybe we would make this lowest common or least common denominator be a private helper method. But just as this example, and because I want to have a method in here that takes in an object parameter so we can look at how that works, I'm going to have it be a public method. So it's going to be public int find least common denominator, and I'll take in some other fraction as a parameter. Okay, so this is an object. Remember that Java is passed by value, but the value of objects is a memory address. So what is coming into this method is a memory address of this other fraction. So any changes I make to that fraction inside this method, that will be seen, that will change the fraction outside the method because it's one fraction. Okay. So how can we find that least common denominator? Well, we're going to use a mathematical formula that finds the lowest or least common multiple of any two numbers. So the least common multiple of any two numbers a and b, you can take a times b and then divide by actually the greatest common factor of those two numbers, and that will give you the least common multiple. So to find the least common denominator, I will find the least common multiple of the two denominators. Okay, so we're going to calculate these two things to find our least common multiple. And again, don't worry about this formula. This is just a formula from mathematics. It's not something you'll need to use again, or don't worry about figuring out why it works if you don't want to. We're just going to use it and use it to find our least common denominator. So we'll say our least common denominator. Our least common denominator numerator, I'll say top instead of saying numerator. So that's going to be this part. That's going to be the two denominators multiplied together. You'll notice that this is an instance where I have decided to use the this dot to indicate you're talking about the denominator of this current object and the denominator of the other object. So this is an instance where I do choose to use this dot. You would not have to. Code would work without it, but I like it because it kind of makes it clear, and I think it makes it a little more readable. And then we can have our least common denominator bottom is just, I'm going to invoke that same method again, that find greatest common factor of the two denominators. So again, you're seeing how we're reusing that code. It's a good thing we had it in a method. And then I'm going to just return the division of those two values. And that's going to be my least common denominator. Okay, so let's go back to our tester. And here we'll see that our Oops, if I do Control V, okay. Sorry. What do I say? Find least common denominator. Sorry. I'm trying to save you from watching me having to type this and then I typed it wrong. Okay, so if we want to, let's say the lowest common denominator of 3/15 and 4/2 is 30, right? That is the smallest multiple of those two numbers. Of 1/2 and 1/4, it's 4. Of 5/3 and 4/3, it's 3. And you can see how we invoke this method is we invoke it on an invoking object, one fraction, and we pass in another fraction as a parameter. Okay, so here's some examples of invoking that method. So this could also potentially be written as a static method. You perhaps would create a static method where instead of passing in one fraction object and then invoking with the current fraction, you could also create a static method where you sent in two fraction objects and then sent back the least common denominator. That might actually make a little more sense. But again, for this example, I just wanted to show you what it looks like to have, this object coming in as a parameter. And the other thing I want to show you about that is just a reminder of this pass by value. So I wanted to show you so inside the method, the num is okay, so this is just for demonstration purposes. This has nothing to do with the least common denominator, but inside the method, let's take in what that numerator is, and then let's change it. Okay, and now let's go back into our find least common denominator, and we'll look at these. We'll just say, okay, so we'll look at fraction 7, and then we will invoke that least common denominator, and I'm just ignoring the output because I don't care about that. I just want to show you what happens when you modify an object inside a method. So when I do that, you'll see that, because I already invoked it there. Before we invoke that method, fraction 7 is 1/4. Inside the method, the numerator is 1. Before I change it, I then change it, and outside the method, it's now 100, right? So I changed it inside the method, and it affected it outside the method, right? Because it's one object being passed around. Okay, so again, there's an example of that pass by value. If you modify things, if you put that object instance data variable on the left-hand side, this would also be the same if I said, set numerator to 100, same thing. That object will be modified outside the method because it's just one object being passed around. So you have to be very careful with that and always think about how that pass by value works in Java. One last thing to think about, if we were to, instead of modifying the object, if we were to take this formal parameter and point it to a new fraction, now it's not going to be affected outside of the method. And if you'll see here, now it's not. Inside the method, the numerator is 100, but outside it's still 1. Because what we've done here is we've broken that alias link between the formal parameter and the actual parameter. Okay, this is almost always a mistake. There's very few times you actually want to do this. So be very careful about putting a formal parameter on the left-hand side and pointing it to a new object. That usually is a mistake. That's usually not what you want to do. Because the whole reason you sent this parameter in is because you wanted to use it, not because you wanted to create some new fraction. If you want to create a new fraction, declare a new local variable to do that. Okay? All right, so just a little, again, refresher about the pass by value. So let's write our last static method called create reduced fraction, taking in a existing fraction. Now, the idea here is that I want someone to say, well, I'm going to give you a fraction. You create a brand new fraction that's reduced, but don't change this fraction. So I'm giving you 2/8. I want you to give me a fraction of 1/4, but I don't want you to change the 2/8. I want 2/8 to stay what it is. Okay? I'm making this a static method because, this is functionality associated with the class. It's associated with the idea of fractions, not necessarily with any one fraction individually. Similar to this again, I think probably would have made sense to make this a static method as well, where you would take in two fraction objects, but I just kind of want to show you all these different ways of writing things. So probably would also be static. But we'll show you this one static here. So again, we're going to take in a fraction, we're going to reduce it, and send back that new fraction. So what we don't want to do is this, right? Because what that would do is it would change this actual fraction and then send back a same reference to that same fraction, right? I haven't created anything new here yet. I've modified the parameter and I've returned it. I didn't create anything, right? What I want to do is I want to create a new fraction and then reduce that fraction. So what I want to do is create a new fraction using the same values, so the numerator and the denominator that are passed in as a parameter. And now anything I do to this new fraction, this new object, won't affect the parameter at all. So now I can say, reduce fraction dot reduce, and then return that reduced fraction. Okay. Anytime that you want to create something new, you got to look for that new keyword. Sometimes it'll also happen with a factory method, which is kind of what we're creating right now. But you want to think about, if you're just using assignment statements without a new in there somewhere, you're not creating anything new. You're just changing existing references and kind of swapping them around or whatever. So let's go over to our tester here, and here I've created a fraction 11 that's 2/6. I will then invoke my static method. Note that to invoke it, I'm invoking through the name of the class, so fraction dot, and then passing in my fraction parameter, and then I'll print out the original fraction as well as the reduced fraction. So here you can see that we still have fraction 11 is 2/6, and the reduced version is 1/3. So we haven't modified that parameter, which is what we wanted to avoid, and we've created that reduced version. So there is an example of writing a class and kind of writing some public methods, some static methods, taking in objects as parameters, using private helper methods, keeping in mind this idea of functionality and encapsulation. Encapsulation meaning that each class is in charge of its own functionality, and that its information is private within the class. So keeping those instance data variables hidden. One other kind of, I guess, sort of obvious example or kind of artificial example of another thing I'm trying to explain about encapsulation is, let's say, for example, we wanted to print out a fraction and we said, well, I want to print my fraction, so I'm going to print, frac12.get numerator, and then I'll print my, my line there, and then I will print the denominator. Okay, so if I were to do that instead of invoking toString, it will print out what I want it to print out, right? It will print out 1/3. But what this does is it doesn't allow that fraction object to be in charge of its own functionality of figuring out what its text representation is. So what we should do is we should say, the fraction class knows best how to print a fraction. So I am going to just invoke toString and allow the fraction class to figure out what that toString representation is. So that's, again, sort of an artificial example, but the general idea is let each object, each class be in charge of its own information. Trust that that class knows the best way to do something. So when you want to ask that class to do something, use the existing methods written in that class to ask an object to complete some task. So again, there you go with an example of creating a class, and I'm going to clean up this tester a little bit. I'll make some comments as to what this code does, so hopefully you can download it and kind of play around a little bit. I also encourage you to change this to be static and kind of see how that changes things. What do you need to change in terms of invoking, and what do you think, should this method be static or not? I also encourage you to consider writing an add method. So you could write an add method where you take in a fraction as a parameter and then use your find least common denominator method to find that least common denominator, and then add those methods and maybe create the new fraction to send back or something like that. So that would be a good practice as well.